All right, so we're going to be just walking through a little bit of the notes real quick. I'll do a few of the examples just to kind of walk you through how to do them, but I'll try to keep this fairly quick. So we've talked about a mole a little bit in the past, and it's just a number that we use a lot in chemistry. And just like we would say dozen for 12 for a mole, it's also known as Avogadro's number, and that's 6.02 times 10 to the 23 of any of whatever it is that we're talking about. Those could be atoms, molecules, compounds, or something that we would just call formula units. Basically, a formula unit is the same as a compound. If it's a covalently bonded group of atoms, that would be a molecule. If it's an ionically bonded group of atoms, that would be a compound or a formula unit. You can see the examples just to see how large that number is. But then we're going to look at how to do some calculations here. Again, it's using some dimensional analysis, which we've done a little bit in the past. So if we want to convert from the number of atoms, the first example here is with the sodium atoms. So if we want to know how many atoms are in a given number of moles, and by the way, the abbreviation for mole is just MOL. Get to save the E. And so you first just write down the value that you're given, the original measurement, in this case 0.120 moles of sodium, and you put that over 1. And then you're going to multiply, draw a line, and then you're going to put in your conversion factor, or what's known as a proportionality constant. Basically, two values that relate to each other. Now, since we have moles of sodium here and we want to cancel that unit out, we're going to put moles of sodium on the bottom. And we want to know how many atoms of sodium. And then you just put that relationship, which is 6.02 times 10 to the 23 atoms of anything are 1 mole. And then you just plug that into the calculator and you would get 7.22 times 10 to the 22 atoms of sodium. Going the other direction, if you are given the number of atoms, in this case of potassium, and we want to know how many moles that is, you would start with the given value of atoms. We want to cancel atoms and we want moles. So in this case, the 6.02 times 10 to the 23 goes on the bottom. So you're going to be dividing that. And just remember that when you use your calculator, you want to use that second comma to get that capital E. And that's so that you don't have to use parentheses, because if you type it in as 6.02 and then hit times 23, that's going to put that on the top. And that will give you the wrong answer. So make sure you practice that. Make sure you're getting the correct answer. You can also go between numbers of molecules and moles, or moles and molecules. In this case, 7.92 moles of carbon dioxide. We want to know how many molecules, so you would start with the measurement that you're given. In this case, 7.92 moles of carbon dioxide. And we're going to cancel moles of carbon dioxide. We want molecules. And just like anything else, a mole is going to be 6.02 times 10 to the 23 of those. So 1 mole is 6.02 times 10 to the 23. And this one down here, very similar. Here you're given the number of formula units of calcium chloride. We would say formula units because this is an ionic compound versus the molecules up here for covalent. So starting with 1.39 times 10 to the 19 formula units times, draw your line. We want formula units on the bottom so it cancels. And then we want moles on top. And 1 mole is Avogadro's number.